During the 19th and the early 20th century, science became extremely popular. There began to develop an empire of science where everything was defined by science itself, including knowledge. I won't believe it unless it can be proven to me by the scientific method. The problem with that statement is, first of all, very few people who say that really know what the scientific method is. The second is that statement itself cannot be proven by the scientific method. Science is a subset of philosophy, and philosophy is a subset of theology. But people thought that science was everything. Everything needed to be scientifically proven to be true and good. We have a period of time when science becomes extremely powerful, and because of that, people generally don't think in terms of limitations, the boundaries to science. Can science do everything? No, there are certain limitations. So I want to briefly discuss some of the most important limitations to modern science. First of all is the complexity problem. The world around us oftentimes can be so complex that we can't even come up with a theory. We can't even come up with an answer to the questions that we ask. Then there's also problems with experimental technology problems. In other words, to be able to test our theories, we have to develop what scientists often call black boxes, these devices to be able to have the instruments to test our theories. Well, many times our theorizing can outstrip our technology to develop the machines that we need, the microscopes, the telescopes, or whatever, to even see the plausibility of our answers. Another major limitation with science is the preservation problem. In Ecclesiastes, I believe it is, Solomon says, what is lacking cannot be counted. And science often faces this. The information they need has not been preserved. It's been ground up as sand grains and delivered into a sea somewhere, and so it no longer exists. When I was studying science at SMU, I had a friend of mine that spent a whole summer out in the field doing field work and couldn't find any outcrop to answer the question that he had written his proposal for, and so he invited his main advisor out, and they spent another few days scouring the countryside, and they also couldn't find any outcrop, any layers of rock to answer the question. And then the nightmare occurred, and that was the preservation problem. He just wasted a year of his life in preparing this proposal because the data that he needed was no longer in existence. There's also something called the sample problem. In other words, whenever we study nature as scientists, we cannot study everything at once. We have to be very selective in terms of the sample because of time constraints and financial constraints and other types of things. And so we have to take a sample and hope that that sample is representative, that we can draw data, we can draw information from that sample. And so there are many sample problems. One would be sample size. Is our sample large enough to be representative? There's also the sample contamination problem, that very often in the way that we collect the sample, we can contaminate it in different ways. There's also the sample processing problem, in that as we're processing the sample, we can often change the sample itself. And so if you're using acids to dissolve a certain mineral type to extract fossils, if those fossils are made up of the same mineral type, you can actually dissolve the fossils that you're studying. So there's a processing problem, many types of processing problems. Even the idea of transmitting information from your observation onto the data sheets can be a processing problem. I was watching a program many years ago of geologists working out in the field, and one of them was reading the monitor and the other was recording the data. And it was very interesting as they were saying the numbers. They sounded like they had some kind of mental problem. They were saying 1, 2, 4, 6, 7, 8, And so they were emphasizing all the different phonemes of every number they were saying because of this sample processing problem. And that you may mishear or misspeak a certain number, and that could change your data quite a bit. There's also the sample bias problem, in that whenever the scientist is working on a particular answer to a question, they begin to like their answer, and very often the fact that they like that answer, they will consciously and in some cases subconsciously bias the data to get the results that they want. Alright, so complexity problem, experimental technology problem, preservation problem, sample problems. We can see there are quite a few limitations to science. There's also something called the theory-laden observation problem, and the fact that whenever you are doing an experiment and you're looking for something, you're generally going to find what you're looking for, and you've actually designed the experiment to find certain things, i.e. what you're looking for. So that means you're not going to find the things that you weren't looking for, but very often the things that you weren't looking for is the very thing that will lead you into a new discovery. And we see that in the history of science, that very often when you have a major breakthrough in science, it's because of something called serendipity. You find something by accident that you weren't looking for. And so the discovery of radioactive minerals occurs because someone wrapped a rock up in a photographic film rather than a piece of paper, and the photographic film was developed by the rock, and so they discover radioactivity. The discovery of the nucleus of an atom, the same way. They set up the technician misheard the scientist, and he set up the recorder in a different area, and they actually revolutionized the way that we see the atom. Why? Because of an accident, because of a mistake. It's when we do things differently that we find things that we're not looking for. And so accidents will very often lead us to new understanding, new discoveries. And then last but not least, one of the key elements of limiting science is the integrity problem of the scientists themselves. It's very important that scientists be truthful, and as our culture begins to shift toward a devaluing of values, of virtues such as honesty and integrity, that is going to impact science. That happened when I was at the university. There was a story that spread of a student who was working on his PhD, and he falsified a significant amount of his data. And the problem was he got his PhD and his dissertation was used in several other dissertations. It was finally discovered that he had falsified his data. Not only was his dissertation rejected and his degree stripped, but the other degrees that had based their work on his also were reevaluated, and one of the young persons lost their degree also because it was false. The data that had been added to the scientific world was something that was incorrect. And so if more and more scientists lose integrity, that will be a limitation, a problem for science in the future.